Time, as we understand it, the universe is comprised of a sequence of moments arranged in a particular order. As we go through life, we have an inherent sense that the time moves forward, bringing about changes in our physical strength and occasionally granting us wisdom. Over the course of time, civilizations emerge and perish, sometimes leading to their own destruction. These are the effects that prompt us to observe, experience, and reflect upon time. Yet, through deeper contemplation, the question inevitably arises: what truly defines the essence of time? In his book, The Order of Time, physicist Carlo Rovelli says that time is our ignorance. It is a succinct remark, but again, what should we derive from this expression? To gain insight into this matter, let us begin by exploring the classical approach within physical systems. To the extent of human perception and understanding thus far, the central concept at play is entropy. Entropy is a fundamental concept in physics and thermodynamics that measures the level of disorder or randomness in a system. It quantifies the number of possible microscopic configurations that a system can have while maintaining the same macroscopic properties. In simpler terms, entropy is a measure of the system's uncertainty or the degree of chaos within it. When the number of possible microscopic arrangements is high, the entropy is also high, indicating a greater degree of randomness or uncertainty in the system. Conversely, when the number of possible arrangements is low, indicating a more ordered or organized state. So, entropy is often associated with disorder, and it is more accurately a measure of the system's microscopic complexity or the number of available states. Therefore, entropy is not directly calculated as a measure of disorder. Instead, it is a statistical concept used to quantify the distribution of energy within a system. This concept can be likened to the state of a room that becomes increasingly chaotic if we neglect to tidy it up. Over time, the disorder within a closed system tends to increase consistent with meaningful statistical manner. When dealing with complex systems involving numerous entities, our approach as rational beings is to derive meaningful conclusions from our observations and measurements, relying on statistical methods rather than exact determinism. The limitation arises from the fact that human perception, being a part of the universe itself, is inherently restricted. As a result, we are unable to fully grasp the exact behavior of each individual particle within a physical system, let alone comprehend the working of the entire universe. In simple terms, statistics serves as a means of acknowledging our ignorance, as Rovelli said, or lack of precise knowledge about ourselves and the world around us. In the realm of classical physics, it is apparent and intuitive that the blurring of reality occurs due to our inherent lack of exact knowledge about our surroundings. Furthermore, the laws of physics possess the property of time reversal, meaning that they are indifferent to the direction of time. The progression of time towards the future is determined merely by our perception, and this illusion has something to do with the increase of entropy. When considering quantum physics, the situation becomes even more intricate. Despite its precise experimental predictions, the fundamental understanding of quantum theory remains elusive. It relies on the implementation of probabilities and principles of other peculiar nature of matter and energy. In quantum mechanical interpretation of matter, there is even a phenomenon called uncertainty principle. In contrast to classical physics, the uncertainty principle in quantum mechanics asserts that it is impossible to simultaneously determine position and velocity of a photon or electron like particle with absolute precision. Moreover, the wave particle duality conundrum has not been understood very well yet. Regarding this issue, there is also a concept like measurement problem, meaning that if you measure a quantum state of matter, its wave function collapses and acts as a classical particle. Otherwise, before measurement or any intervention, the quantum state resides in its indeterministic wave state. This indeterminism in quantum mechanics is commonly illustrated by the famous experiment referred to the double slit experiment. It demonstrates that particles such as electrons or protons can exhibit both wave like and particle like behavior simultaneously. The outcome of the experiment, whether a particle passes through one slit or both, is fundamentally uncertain until a measurement is made. The indeterministic nature of quantum mechanics challenges our classical intuitions and suggests that the universe operates in a fundamentally probabilistic manner at the microscopic level. But this feature has profound implications for our understanding of reality, the nature of causality, and the limits of predictability in the quantum world. As humans, even with the aid of most advanced supercomputers, our understanding of nature is limited to statistical interpretations. Our inability to comprehend every piece of information in the universe is a testament to our inherent ignorance. If we could perceive every particle and its interactions precisely, time would cease to exist. Beyond the conventional interpretations of physics, both classical and quantum, there exists some metaphysical explanation. Among these perspectives, irrespective of its lack of scientific foundation, one could envision a scenario where a supreme being possessing omniscience and omnipotence across all dimensions meticulously crafts each infinitesimal moment of our existence and arranges them in a sequential manner, thereby imbuing our lives with purpose and significance. As John Wheeler said, time is what prevents everything from happening at once.